Okay, in this section we're going to work on multiplying algebraic expressions, and we're going to look at like 3 different scenarios, which, you know, we can see how they're all related to each other. The first scenario here we really already know how to do. If we're multiplying 2 things that don't have any addition, so 2 monomials, right, there's only one term, basically we're going to apply the rules of exponents that we've already learned. We know that we can rearrange the order of multiplication all we want. So we've got in this first example 3c to the 5th times negative 4c squared. So I could multiply the 2 coefficients and then multiply c to the 5th times c squared, and that gets us negative 12, and we can add those exponents to get c to the 7th. And in fact, a lot of times people will skip this step where they kind of rearrange the order of the factors, and they kind of do that mentally and just get this final result, which is okay to do if that's something that you feel comfortable doing. That's not considered poor communication. After you do enough of these, you'll probably find you kind of just start automatically doing that anyway. And another example here, negative 2b squared y cubed multiplied by negative 9aby to the 5th. So I'm going to do some of this organization kind of mentally here. I've got negative 2 times negative 9. That is a positive 18. Next we have b squared and a factor of b. And I think while I'm at it, I'll go ahead and write that factor of a first. So we got a, b squared times b, and then y cubed times y to the 5th. And simplifying this gives us 18a, b to the 4th, y to the 8th. Just adding those exponents. I don't know why I wrote b to the 4th. Sorry, b squared times b to the 1st is obviously b to the 3rd. Alright, next. We've got to be careful here. There's a little bit more going on. Where in the middle we have this factor that's being cubed. So we actually need to deal with that first. And I'm going to distribute that exponent to those factors inside first. So 3 times 2 cubed times x squared cubed times y cubed times a negative xy. Now if I want to know what the coefficient is going to be, I can just multiply all the coefficients, right? I've got 3 times 2 cubed, and then it's also going to be negative because I'm multiplying it. I could think of that as having a factor of negative 1. So 8 times 3 is 24. We got a negative 24. X squared all cubed is x to the 6th times y cubed, and then times xy. And now we'll just do the last steps to simplify. X to the 6th times x to the 1st is x to the 7th. And then y cubed times y is y to the 4th. So these 3 examples just sort of illustrate it's kind of an extension of what we've learned to do when we're working with exponential expressions, how we simplify those. In the next scenario, we're going to consider what if one of our factors has addition or subtraction. And in that case, we're going to use the distributive property. So in part A here of example 2.42, we're going to distribute this factor of negative 3b to the 2 terms inside those parentheses. So at negative 3b times 2b squared, bringing over the minus from the parentheses, and then negative 3b times a. Now each of these individual products, I'm going to simplify like we did in the last example. So negative 3b times 2b squared, the coefficient, negative 3 times 2 is a negative 6, b times b squared is b cubed, and this will end up, we're subtracting a negative, so that'll end up being plus 3ab. Now let's do another one. Here I've got a factor of 5st that I'm going to distribute to each of those two terms. So 5st times 3st squared minus 5st times 2sw. Simplifying each of these products, the first one ends up being 15 s squared t cubed, and then the second term minus 10 s squared tw. All right, one more example here in this section, or in this part of this case, this part of the section. Here in part C, I've got 3 terms inside, and so far in these last two, we just had 2 terms inside, but this property holds no matter how many terms are inside. Here we're going to do one with 3 terms. If I had one with 5 or 7 or 10 terms, I would still just distribute it, this one factor sitting outside, to each of the terms sitting inside those parentheses. So this is going to look like the following. Let's say I've got negative 2x times 3xy squared minus, I'm bringing over this minus sign here, a negative 2x times 2x squared y, and then plus, I'm bringing over that plus sign, negative 2x times y squared. Now each of these individual products I'm going to simplify like we would on the earlier simpler examples. In the first product here, I've got a coefficient of negative 6. X times x is x squared, and then I've got a factor of y squared. In the middle, I'm subtracting a negative. This product is going to be negative here, so once I subtract that, it'll be a plus. 2 times 2 is 4. X times x squared is x cubed. And then I have a factor of y. And then last, we're going to end up with a minus 2xy squared. All right. Now the next group of examples are going to show us how we multiply two things that both have some maybe addition or subtraction happening. So you may be familiar with the mnemonic device FOIL. And this is if we're multiplying 2 binomials. So each of the factors has 2 terms. And FOIL stands for first, outside, inside, last. And that works as long as both of your factors have just 2 terms in them. We'll find that FOIL breaks down once we have 3 or more terms in one of our factors. And so I'd like to not rely on FOIL. In this example here in part A, I'm going to show you what FOIL means in this context. So this would mean the 2 first terms, first times first, so that's x squared. Outside means the 2 outer terms, that's 3x. Inside means the 2 inner terms, and that would be a negative 2x. We multiply the 2 inner terms. And then last means multiply the 2 last terms, negative 2 times negative 3, and that's minus 6. And then we combine like terms. We have some like terms in the middle here, so we have x squared plus x minus 6. So again, FOIL works as long as you only have 2 terms in each factor. So I'm going to show you another technique here, and I'm going to start with this example, and that is you simply list the terms of one factor. We're going to make a little grid, and across the top I'm going to list the terms of one factor. I've got an x and I've got a negative 2, and the other factor I've got an x and a positive 3. So I'm making a little grid, and then I simply, in each of these spots here, I'm going to do the multiplication indicated by the row and column. So in this first spot, I've got x times x. That's x squared. Moving over to this spot here, I've got x times negative 2. So that's a negative 2x. I'm going to move to the second row now. My first entry in the second row is 3 times x, so that's a positive 3x. And my last entry here in the second row is 3 times negative 2, or negative 6. So those are all the terms I'm going to add together. And what often happens when you set it up this way is you end up with your like terms along this diagonal. So 3x plus a negative 2x is equal to just a positive x. And then you add those together, and you come to the conclusion that the same one that we got using FOIL, that this result is x squared plus x minus 6. This technique with setting up the grid is the one you'll see me use most often in doing the examples throughout the course. Whenever I need to multiply things, you'll see me set it up that way more often than any other technique. Alright, x minus 5 in parentheses squared. Now, I'm going to give you a few seconds to think about how we should set that one up. And hopefully we're remembering that we have to be super extra careful whenever we see addition or subtraction. A lot of our properties that we like to apply kind of don't always hold when we're adding or subtracting. And so what we want to remember right now is that we cannot distribute an exponent over addition or subtraction, and we should rely on the fact that if I square something, it means I'm going to multiply it by itself. So this is x minus 5 times x minus 5. And I'm going to set up my little grid. So along the top row here, I've got x times x, which is x squared. Moving over, I've got x times negative 5, which is negative 5x. In the bottom row, negative 5 times x is negative 5x. And last, negative 5 times negative 5 is a positive 25. So we get x squared. Let's see, our like terms here are negative 5x and negative 5x, so that's a minus 10x. And then plus 25. Note that we did not get x squared minus 25. We cannot distribute an exponent over subtraction. Next, we've got a product here. Note that there are 3 terms in the second factor. So here's an example of a product we simply could not find if we relied entirely on FOIL, right? FOIL does not apply here in this problem. So I'm going to use the grid here. I've got my factors 5s minus 3t, and then these other terms, s squared positive st minus t squared. Across the top row, my products are 5s cubed minus 3st, minus 3s squared t. In the middle row, 5s squared t, and then minus 3st squared. Along the bottom row, minus 5st squared, positive 3t cubed. Notice that I've got some like terms here. That'll give me a positive 2s squared t, and also I have like terms here. That'll give me a negative 8st squared. So this becomes 5s cubed plus 2s squared t minus 8st squared plus 3t cubed. Okay, one more example here. 2x minus y in parentheses all cubed. By now, we've learned from a couple examples ago, kind of reminded ourselves, we can't distribute an exponent over subtraction or addition. So we're going to apply the fact that we know that when I cube something, I'm going to multiply it by itself 3 times. So 2x minus y, 2x minus y, 2x minus y. Now, there's not a single grid that we could set up that'll take care of this whole product at once, but what we can do is deal with one product at a time. So I'm going to do the first product there. I could have chosen the last two, but I'm just sort of grouping it as the first two, and then I'll bring down this factor of 2x minus y and then multiply that one at the end. So I'm going to make up my table here. 2x minus y, 2x minus y. Across the top row here we got 4x squared and a minus 2xy. Across the bottom row we got a minus 2xy and a plus y squared. We got like terms here, so that's a minus 4xy. So that product in the beginning is 4x squared minus 4xy plus y squared. And now I'm going to multiply that by 2x minus y. So I'm going to write out my factors here. Let's say 4x squared minus 4xy plus y squared. And then the terms of my other factor, 2x minus y. Across the top row, our products are 8x cubed. Then we've got negative 8x squared y and 2xy squared. Along the bottom row, negative 4x squared y, positive 4xy squared, and then negative y cubed. We've got our like terms along this diagonal here, which gives us a negative 12x squared y, and another set of like terms here, which gives us positive 6xy squared. So overall, this product is equal to 8x cubed minus 12 x squared y plus 6xy squared minus y cubed, and that is our final result. Oops.